How many grams are in 1.25 moles of NaCl? How many moles are there in 3.78 grams of H2O? How many valence electrons does nitrogen have? What is the electron configuration of magnesium? To answer any of these questions, one must use the periodic table of elements. Yes, that table of elements posted in every single chemistry classroom. Chemists use this table daily and for a wide variety of calculations and concepts. But how did it come to be, and how was it that it was arranged in this way? Dmitri Mendeleev is called the father of the periodic table. He was born February 8, 1834 in the Russian Empire, and is the youngest of at least 14 children. At age 13, his father died, which left his mother to support the family. Shortly after the death of his father, the factory his mother was working in was destroyed by fire. In 1849, with the majority of his family out of the house, his mother moved him to Moscow, then to St. Petersburg to get a higher education. This led him to becoming a teacher. When he started to teach the 63 known elements, he tried to classify the elements according to physical properties. He then became consumed in organizing these elements. He started to organize the elements by increasing order of atomic weight and properties. He noticed a pattern when he left blanks in certain places. He hypothesized that those blanks were elements that had yet to be discovered. And he went far enough to predict elements. He predicted gallium, but he called it Eureka aluminum. This table shows Mendeleev's predictions versus the actual values for gallium. On March 6, 1869, he made a formal presentation in which he released his version of the periodic table. The table he presented in 1869 is almost identical to today's table. When you compare today's table and Mendeleev's table, it can be noted that Mendeleev's table appears to be on its side, and Mendeleev's table also has fewer elements on it than today's table. Mendeleev dedicated his life to science and chemistry. His organization of the periodic table ended up being his biggest contribution to the field. Mendeleev's table was organized in such a way that when Rutherford and Thomson discovered the proton and electron, trends that were observed between these particles, like valency, reactivity, and ionic nature, were already observed on the table.